So we're on factor theorem. So the factor theorem states that if f is a polynomial function, then x minus c is a factor of f if and only if f of c is 0. So we are saying that if you notice, this is a linear factor, that if you substitute c in the polynomial and the remainder is 0, because f of c is also the remainder. If you get the remainder as 0, then is a factor. From our normal sense, if something is a factor of something, means that if you divide it, it will give you no remainder, as the remainder is 0. So let's look at this question. They say use the factor theorem to determine whether this function has the remainder, has the factor as x minus 1 and also x plus 1. So let's check. So if the remainder is 0, you know that. So if we substitute, if for the first one, if x minus 1 is 0, that's substituting x as 1. So then let's check f of 1. We have 1 cube, 2 times 1 squared, minus 5 times 1 plus 6. So this is 1 minus 1. So it will give us 0. Yes, this is 1 minus 2 minus 5 plus 6. Yes, 1 minus 2 is minus 1. Minus 1 minus 5 is minus 6. So this is 0. So it's a factor. So this is a factor. So let's test the other one. If x plus 1 is 0, then x is minus 1. So if I substitute f of minus 1, let's see, minus 1 cube minus 2 times minus 1 squared minus 5 times minus 1 plus 6. So this is minus 1 minus 2 plus 5 plus 6. I think we're okay. That's plus 5, 6, that's 2 minus 1. So let's know whether it's a factor. This is minus 3. Minus 3 plus 5 is 2. So we have 8. We have 8. So not a factor. The remainder is not 0. So not a factor. So that's all about factor theorem. So once you substitute the value of c, remember it must be a linear factor. It must be a polynomial of degree 1. If you substitute and the answer is 0, you know that is a factor. Thank you.